And for this last example, we're asked to integrate from 2 over the square root of 3 up to 2 t inverse secant t dt. Now, in this case, I'm going to let u equal the inverse secant of t. And if you differentiate this, and this is probably not something that you have memorized, but in the formulas that are in the Start Here module, you'll be able to find this form. The derivative of this is 1 over the absolute value of t times the square root of t squared minus 1. Now, if u is the inverse secant of t, that leaves the t as my v prime. And if v prime is t, then v is 1/2 t squared. So I can go ahead now and do my integration by parts. This integral is going to equal u times v. So I'm going to actually put the v first. So that's going to be 1/2 t squared times the inverse secant of t. And we're going to evaluate that from 2 over the square root of 3 up to 2 minus, let me go ahead and get my bounds written here. We're going to look at the u prime. So inside this second integral, I'm going to have 1/2 t squared times 1 over the absolute value of t times the square root of t squared minus 1 dt. Now inside here, the t squared and the absolute value of t, I am going to be able to cancel. So we'll be able to clean this up just a little bit, and I'll come back to that momentarily. When I come over here, I can start to evaluate. I'm going to put that 1/2 here. So starting with the 2 squared is 4, so I have 1/2 times 4 times inverse secant of 2 minus 1/2 times t squared, when t is 2 over the square root of 3, is going to be 4 over 3 times the inverse secant of 2 over the square root of 3. Okay, and we'll just work that out as we go. Now coming back over here, I said before that the t squared and that t in the denominator will be able to cancel, and I'm going to also take the 1/2 and bring it in front. So I have 1/2, or minus 1/2, and we're integrating from 2 over the square root of 3 to 2. What am I left with? T over the square root of t squared minus 1. To integrate over here, I'm gonna do a u substitution, not to be confused with the u that we had at the top, but a separate u substitution. So if you don't want to use a u here, you can use a different letter if it makes you happy. But I'm going to let u equal t squared minus 1. Then du is equal to 2t dt. So here is the 2 squared minus 1 in the denominator. I have a t dt, I just don't have that 2, but I can easily put a 2 up here in the denominator by putting another 1/2 in the front. I'm going to come back to all of this here momentarily, but I'm going to rewrite this as minus 1/4. And again, by putting that additional 1/2 in front will let me do the 2t dt. So inside of here, I'm going to have 1 over the square root of u du. Since I've done the substitution, I'm going to change my bounds to match it. If t is 2 over the square root of 3, then u is t squared minus 1. So that would be 4/3 minus 1, or 1/3 is the lower bound. And if t is 2, I'm going to have 2 squared, which is 4 minus 1, or 3 is my upper bound. So it just gives me a much simpler thing here to integrate, but I'll come back to that in a moment. Let me come back over here to the left. So I've got 1/2 times 4, which is just 2. Inverse secant of 2 is pi over 3. Minus 1/2 times 4/3 is going to be 2/3. And the inverse secant of 2 over the square root of 3 is pi over 6. I know I've got a gap here, but it's all good. So if I kind of continue over here, this gives me 2 pi over 3 minus the 2 here can cancel with the 6, leaves me with a 1 and a 3. So I'm going to have pi over 9. And I will be able to combine here. Now, over here, let's go ahead and integrate. So we have minus 1/4. When we integrate 1 over the square root of u, we get 2 times the square root of u. I'm going to integrate that from 1/3 to 3. Now we're just going to evaluate that 2 times the square root of u and just kind of clean everything up. I'm going to end up making a common denominator. So the 2 pi over 3, I can rewrite that multiplying top and bottom by 3 as 6 pi over 9 minus pi over 9. Then over here, 1/4 times 2 is going to give me a minus 2. And then substituting in, I'm going to have the square root of 3 minus the square root of 1/3. So over here on the left, 6 pi minus pi is 5 pi over 9 minus 2. In the parentheses, I've got the square root of 3 minus the square root of 1/3 is the square root of 1 over the square root of 3, so it'd be minus 1 over the square root of 3. And again, I'm going to do some common denominators. So the first fraction, to put that over a square root of 3, we multiply top and bottom by the square root of 3. So we're going to end up with 5 pi over 9 minus 2 times 3 over the square root of 3 minus 1 over the square root of 3. So I have 5 pi over 9 minus, I just realized I made a mistake here. 1/4 times 2 is not 2. 1/4 times 2 is 1/2. Let's rewind that a little bit, fix that up. Some of you might have been watching the video going, you made a mistake. Thankfully, we caught it there. So I have 5 pi over 9 minus 1/2 times 2 over the square root of 3. So that's 5 pi over 9 minus 1 over the square root of 3. And that is a perfectly acceptable answer. Now, if you wanted to, you could write this as one fraction. If you were to multiply the second fraction, numerator and denominator, by 3 times the square root of 3, so 1 times 3 times the square root of 3 is just going to be 3 times the square root of 3. But when you multiply the denominator by 3 times the square root of 3, you get a 9. So you could write this as just one single fraction, 5 pi minus 3 square roots of 3 over 9. You don't have to, but if you're somebody that likes to really clean it up as far as you can go, that's totally acceptable.